Section 1 Introduction. We're going to delve into the world of large language models, LLMs, which are incredibly versatile, capable of everything from generating responses to logical reasoning and even program synthesis. One of the exciting areas of LLM research is their use as planning agents, which are crucial for processing complex language instructions. These agents need to be able to choose the right tools for each subtask. However, LLMs have some limitations, such as not always having the most current information and sometimes imagining tools that don't exist. To address these issues, we can equip LLMs with a relevant set of tools for the task at hand, which helps to keep the information up to date. This process of enhancing LLM input with retrieved information, like relevant tools, is known as Retrieval Augmented Generation, RAG. RAG has three main parts: tool retrieval, plan generation, and execution. In this study, we're focusing on improving tool retrieval, with the aim of also enhancing plan generation. Current RAG methods heavily rely on semantic search for tool retrieval, but this approach has its limitations, especially when the queries are vague or lack context. To tackle this, we introduce context tuning, a component in RAG that comes before tool retrieval. It aims to improve tool retrieval and plan generation by providing a better understanding of the context and the ability to seek context. Our contributions in this study are as follows. 1. We demonstrate that traditional RAG struggles with implicit or context-seeking queries and propose context tuning as a solution. 2. We compare various context retrieval methods on both lightweight models and LLMs. 3. We show that chain of thought, COT, augmentation improves context retrieval when no fine-tuning is applied, but fine-tuning the retrieval model eliminates the need for COT augmentation. 4. We propose a lightweight model using reciprocal rank fusion, RRF, with LambdaMART, which performs better than the GPT-4 system. 5. We show that augmenting the context at the plan generation stage reduces hallucinations. The use of retrieval to incorporate tools into plan generation with LLMs is a growing area of research. Our work focuses on improving retrieval methodologies to enhance the understanding of implicit and ambiguous queries that require context-seeking capabilities. While incorporating tools into generation has been shown to enhance the capabilities of LLM-based planners, these studies mainly focus on clear or unambiguous queries. For question-answering tasks, using any document retriever has been shown to improve LLM generation, with re-ranking further boosting performance. However, using a text-based retriever may not be optimal due to the inadequate information expected from ambiguous queries. Our work shows the inadequacy of text-based retrievers for context retrieval and the need for more advanced retrieval models. Some studies have explored the use of COT mechanisms to generate text that closely matches the semantic similarity of relevant context. While COT augmentation improves upon basic methods, it may potentially increase the input length to the LLM, which has a limited context window size. Therefore, it's preferable to avoid increasing input sequence length if the same or better results can be achieved without query augmentation. Recent studies have shown that LLMs can act as zero-shot rankers through pairwise ranking prompting. While adding ranking for the retrieval component has shown improvement in question-answering tasks, using LLMs for both the ranking task and plan generation doubles the inference cost. We show that our proposed lightweight context tuning method, LambdaMART-based RRF, outperforms both the fine-tuning approach and GPT-4-based COT augmentation. In our experiments, we train and evaluate tool retrieval and planning with and without context tuning. We use synthetic application data to simulate real-world scenarios for a digital assistant. The data covers 7 commonly used applications: mail, calendar, Google, music, reminders, notes, and phone calls. We generated this data using GPT-4, ensuring diversity in the dataset to reflect a wide range of user personalities. The synthetic dataset contained a diverse range of context items spanning various applications. A total of 791 distinct personas were synthesized, yielding 4,338 unique implicit queries for training and 936 implicit queries for evaluation. We also developed a toolbox containing APIs for each of the applications we considered. This toolbox was created using in-context learning with GPT-4 and contained a total of 59 APIs distributed across the applications. To simulate user interaction with a virtual assistant, GPT-4 was also utilized to generate realistic queries grounded in the application data. Following this, we employed GPT-4 to retrieve the appropriate tool from the generated toolbox in response to these queries. Finally, GPT-4 was used to resolve the tool's API with the correct parameters. This methodology provided a comprehensive and realistic dataset, essential for the evaluation of our context tuning approach in RAG-based planning systems. Section Summary. Large language models, LLMs, are powerful but have limitations such as outdated information and hallucinating tools. Retrieval Augmented Generation, RAG, aims to address these limitations by providing LLMs with relevant tools. In this study, we propose context tuning as a component of RAG to improve tool retrieval and plan generation by enhancing contextual understanding and context-seeking abilities. Our experiments show that our proposed lightweight context tuning method outperforms fine-tuning approaches and GPT-4-based COT augmentation. Section 3.2 Context Tuning. In this section, we'll discuss our method of comparing different ways of retrieving context. We use both text-based and vector-based methods for this. We create different context stores by organizing context data for each persona and train models to carry out a federated search. We use query and persona meta-signals, like frequency, usage history, and correlation with geotemporal features, to carry out the retrieval. We measure the effectiveness of context retrieval using the recall at K and normalized discounted cumulative gain, NDCG at K, metrics. For text-based search, we use an enhanced version of BM25, known as BM25T. For vector-based search, we use the popular semantic search approach. We use GTRT5XL to create query and context item embeddings, which we then rank using cosine similarity to select the top K results. We test both pre-trained and fine-tuned versions of this method. To increase the chances of semantic alignment with relevant contextual elements, we enhance the underspecified or implicit query with GPT-4-generated COT. We test both pre-trained and fine-tuned semantic search versions using COT. We also propose a lightweight model that uses lambda-mart for initial ranking of data across context stores, followed by re-ranking using reciprocal rank fusion, RRF, which has been shown to outperform individual rank learning methods. In terms of tool retrieval, while advanced ranking models can improve the recall, we use the pre-trained GTRT5XL model for semantic search using cosine similarity to retrieve the top K tools. Extending the tool retrieval process to include ranking should be a simple task. The planner's job is to choose the most suitable tool from the retrieved tool list and create a well-structured plan. A plan includes an API call made using the chosen tool and parameters extracted from the query and retrieved context. We fine-tune OpenLLAM AV2-7B for plan generation. To measure the planner's performance, we use the abstract syntax tree, AST, matching strategy to calculate plan accuracy. A hallucination is defined as a plan created using a non-existent tool. As expected, vector-based search outperforms text-based search. However, both methods have difficulty retrieving relevant context for underspecified queries. Fine-tuned semantic search and COT augmentation with pre-trained semantic search both significantly improve retrieval performance. Interestingly, when fine-tuning is used, COT augmentation provides only slight gains, suggesting that similar improvements could be achieved without augmenting the input sequence with COT. Our proposed approach using lambda-mart with RRF performs better than both fine-tuned semantic search and COT augmentation. The performance of tool retrieval using semantic search is shown in the figure. Including relevant context into tool retrieval consistently results in substantial gains across various K values. To establish the planner's lower limit, we remove the retrieval step, while the upper limit is set by directly using context and/or tool labels, effectively using Oracle retrievers. The end-to-end evaluation of the fine-tuned planner shows that the context-tuned planner significantly outperforms the planner based on traditional RAG using semantic search. Importantly, even when the correct tool is retrieved, including relevant context in plan generation, as shown by the upper limit, helps in reducing hallucination.